In this chapter and the next, we're going to be talking about systems of measurement. A measurement has two components. It has a number and a unit. So 4 inches would be a measurement, 7 feet would be a measurement. And these measurements are measurements that would be in the United States customary system of measurement, which we're studying in this chapter. Units of length include inch, foot, yard, and mile. And these are related to one another this way. 12 inches is equal to 1 foot, 3 feet is equal to 1 yard, 36 inches is also 1 yard, 5,280 feet is 1 mile. Our first task here is to talk about converting from one unit to another. And I'll actually show you 2 ways to do that, or 2 ways to think about doing that. One way involves a kind of a rate for conversion. You know 3 feet is 3 feet is 1 yard. So if I put 3 feet over 1 yard, we know that that's just 1. So in multiplying by a fraction like this, we're just multiplying by 1. But this is a handy fraction to use when converting from yards to feet. And here's a handy one to use when converting from feet to yards. It's 1 yard is 3 feet. And once again, 1 yard is 3 feet, so this fraction is equal to 1. Now let me show you how these are used. Suppose we want to convert 27 feet into yards. Here's how we use that idea. We think of 27 feet as 27 feet times a fraction which is composed of yards and feet. And we want to compose that fraction so that the denominator over here contains feet, so that the feet units will cancel. So we're creating a situation like this, where we have the feet here, so we get that cancellation opportunity, and we have the yard business up here. And the relationship here is that 3 feet is 1 yard. You see, it's like that. So we have the feet cancel. And now with this, the establishment of this idea, it allows us to cause this cancellation to occur between the 3 and the 27. So 3 into 27 is 9. So we have 9 times 1 yard. Oh, that's 9 yards. Now, the bottom line of all of this is that we ended up dividing 3 into 27 in order to make the conversion. And we set up the fraction in order to give us a clue as to how to do that, as to what we needed to do. And these conversions are all just a matter of whether or not you multiply or divide generally. But another way to find out what you have to do is like this, is that here we're going from feet to yards, so we're going from a smaller unit into a larger unit. Now, if you're going to describe the same distance using larger units, would it stand to reason that you're going to have more of the larger units or less of them? You see, and it turns out that you will have less of them. If you're using bigger distances, you see, to cover the same overall distance, then you're going to have less of those larger units. Now, I want to emphasize that because it gives you a clue as to whether or not you multiply or divide. If you're going to have less of something, then you generally divide to get less of something. And you multiply to get more of something. So here, if we're converting from 27 feet into some number of yards, we're converting to a larger unit. There will be fewer of them, and therefore we divide, and we divide by the number of smaller units that make up one of the larger ones. And it takes 3 feet to make a yard, so we divide by 3. And that's really what we're doing right here in this problem. We divided 3 into 27 to give 9. So it's just another way of looking at the same situation. All right, let's go through both methods here with this problem as well. It's 5 yards we want to convert into feet. So we think of this as 5 yards as 5 yards times a fraction in which we have the yard in the denominator for cancellation purposes and what we're changing into in the numerator, like this. And now what is this relationship? Well, 3 feet make 1 yard. The yards cancel here. And now notice what we're doing. 5 times 3 feet. 5 times 3, 15. So this is 15 feet. it's handy to retain the units using this method and to actually cancel units as though you were canceling factors in the multiplication process that we're already familiar with. And notice that the foot indicator hasn't gone anywhere, and so we have that foot idea as part of the answer. You see, and that makes it real handy to know what we're talking about down here. Now, let's talk about this from the other perspective, that is, just by thinking, do we multiply or divide? Well, we're going from a larger unit. The yard is a larger unit than the foot. You see, it's longer than the foot is. And if we're going into smaller units, then there will be more of them. To have more, you multiply by the number of the smaller unit that makes the larger unit, 3. So 3 times 5, 15 feet. Suppose we want to convert 40 inches to feet, to some number of feet. Well, once again, using this rate method, we think of 40 inches as 40 inches times a fraction in which the denominator has inches and the numerator has the unit we're changing into, the feet. Now we just write the relationship that we understand here about feet and inches. It takes 12 inches to make 1 foot. So we have this. Now this is a form of 1, you see, which allows us to go through this. The inch business goes out, and now we have the 12 here and the 40 here. We have a cancellation opportunity. Remember, this 40 is in an understood numerator. So we're thinking, gee, let's see, what goes into 12 and 40? And if you don't see anything else, we certainly see that they're both even. So we can say 2 into 12 goes 6, 2 into 40 goes 20. Oh, they're both even again. So 2 into 6 goes 3, 2 into 20 goes 10. And I have, well, gee, it looks kind of convoluted. Let's multiply straight across. 10 times 1 foot is 10 feet. You see, the number part is 10, and the denominator 1 times 3 is 3. So we have 10 over 3 feet. Now, we likely wouldn't leave it like this as an improper fraction. We would go ahead and make this a mixed number. 3 into 10 goes 3 with 1 left over. So this becomes 3 1/3 feet. Now, there is another way. There's another way to look at this, and in certain circumstances, when making a conversion, you want to make the conversion according to the most whole number of the larger unit. How many whole 12s are there in 40? You want to go through the conversion like this. Now, notice that it was 40 over 12, you see, and we were trying to get a cancellation opportunity, which led us to all of this business. But we could have done this. We could have said, well, rather than do it that way, I'd like to know how many 12s there are in 40. So I can actually go through a long division problem like this. I can say 12 into 40. You see now, 12 into 40 goes 3. 3 times 12, 3 times 2, 6. 3 times 1, 3. So 36. And my remainder is 4. Now, often you would put the 4 over the 12, but just understand that we have, what this is 3 feet, and we have 4 inches left over. Now, the 4 inches that are left over, we could say this is 4/12 of a foot, which is 1/3 of a foot, which is what we did over there. Or we could say, gee, we have 4 inches left over. You see, we had 40 inches, we were dividing into 40 inches. We have 4 inches as the remainder, so this is 3 feet, 4 inches. You see, that's another way to express the same result. 1/3 of a foot, after all, over here, the fractional part, is really 4 inches. So sometimes this is the way that we want to write it, and sometimes this is the way we want to write it. Suppose we want to convert 9,240 feet into miles. Well, let's see. It's 9,240 feet that we will write as 9,240 feet times. Now we want to make a fraction that has feet in the denominator and the unit we're changing into in the numerator. And now, what is the relationship between feet and miles? Well, 1 mile is 5,280 feet. You see, so now we have, this is an understood numerator, so we're dividing 5,280 into 9,240. And we can use the calculator, I suppose, at this point. But the feet will go out, and we have, well, let's see. What do we have? We're dividing 5,280 into 9,240, and it'll go one time, and subtracting I get all of this. Wow, and now I have this over that. Well, it turns out that these two, that the fraction that's made here, this is 1 and 3,960 over 5,280, is reducible, and it reduces to 3/4. I believe it does anyway. Let's see, 3 minutes over there. Let me try to do this fast. I'm dividing in both parts by 10. I see that they're both even. I'm just going to take it one little thing at a time, but it's dividing by 2. I get 1, 9, 8, and then downstairs 2 into 5, 2 with 1 left over, 2 into 12, 6, 2 into 8, 4, both even. 2 into 19, 9, 1 left over, 2 into 18, 9. 2 into 2, 1, 2 into 6, 3, 2 into 4, 2. And now I believe these are both divisible by 3. So 3 into 9, 3, 3 into 9, 3. 3 into 13, 4. 3 into 12, 4. Gee, these are both divisible by 11. 11 into, let me go out to the side, 11 into 33 goes 3, 11 into 44 goes 4, so 1 3/4. Now, I went through all of these shenanigans here doing it by hand. Certainly it would be very quick if I did it using a calculator. So 1 3/4 or 1.75 would be the answer over here. Let's come back over here and put it in. It's 1 3/4, and what is the unit? Well, the feet canceled, and I can see that the unit needs to be miles. So 1 3/4 miles. Now, the other way to look at this or to think about it or to get into the calculation of the conversion is this. We're changing from feet into miles. We're changing from a small unit into a larger unit. It will require fewer of the larger units to cover the same distance. To have fewer, we divide. So we're going to divide by the number of small units that make up a large one. Well, it takes 5,280 feet to make a mile, so we're dividing this by 5,280. And that's exactly what we did over here. Just another way to get into the same calculation. Now, suppose we want to rewrite 17 inches as so many feet and so many inches. This is something that I alluded to before. A lot of times when you make a conversion, all you want to do is just rewrite in a simpler way. 17 inches, a 1 foot is 12 inches. So it's a little simpler to think of 17 inches as 1 foot with the leftover inches over here. You see, and I can tell what's left over by division, or I can just think of subtraction since it's only 1 foot. If I have 12 inches, if I have the 17 inches here, and I subtract the 12 inches in the 1 foot, you see what I'm left with is 5 inches. Oh, so the leftover amount is 5 inches. That's one way to do it. Another way is to divide. We could say, well, 12 goes into 17 one time. 1 times 12, 12. Then I'm subtracting here to get 5. So my remainder is 5 inches, and that's what I put here. Let's go through it again with changing feet into yards and feet. You see, so we want a whole number of yards and then the leftover feet over here. And since it's 31 feet, gee, how are we going to divide? What are we going to divide by? Well, again, this is one of those situations where we're trying to change into as many larger units as we can. And when you change into larger units, there'll be fewer of them, and you divide to get fewer. So we're dividing by the number of feet that's in 1 yard, and that would be 3. So we're dividing 3 into 31. 3 into 3 goes 1. 1 times 3, 3. Subtract We get 0, bring down the 1. 3 into 1 goes 0. 0 times 3 is 0, and the remainder is 1. So 10 is the whole numbered part of the answer, and so we have 10 yards and 1 leftover foot, you see. So 10 yards and 1 foot for 31 feet. We can almost see it even more clearly just by thinking that of 3 into 31, almost in your head, you know that it's 10. 10 times 3 is 30, you see, and then the 1 is left over for the 1 foot. Often in real problems, we need to add, subtract, multiply, and divide measurements. Let's go over those processes. If we're adding 9 feet 11 inches to 3 feet 6 inches, we just add vertically. So here 11 and 6 would be 17, and both of these are inches, so inches plus inches, total inches, you see. And then vertically here, 9 and 3, 12 feet. Now, it's often the case in situations like this where we'll end up with more of the smaller unit than we have that makes one of the bigger unit. And this isn't a simple form, so we'd like to rewrite this in a simpler way so that the 12 inches, the foot that is in here in 17 inches, is actually placed over here, and the leftover inches are over here. Now, there are a lot of ways to think about that. We can divide 12 into 17 and talk about the leftover inches, or we can just imagine it. We can just kind of subtract, just take 12 from 17, you see. So the 12 that we take from the 17 inches is actually 1 foot, and that 1 foot is added here to make 13 feet. Oops, 13 feet. And when we take that 12 feet out of the that 12 inches out of the 17 inches, we're left with 5 inches. So we have 13 feet 5 inches. Now, as I say, there are a lot of ways of thinking about this. There are a lot of ways of writing what you're thinking. Here's another way to write the similar idea. We can go through this kind of process. And this might be a thought process that we go through, but we really don't actually write all of this down. But it's the notion that we have 12 feet, and 17 inches is really 12 inches plus 5 inches. You see, and the 12 inches, though, is really 1 foot. So this is 12 feet plus 1 foot plus 5 inches. And now the 12 feet plus 1 foot, oh, that's 13 feet. Plus the 5 inches, well, that's 13 feet 5 inches. You see, so we get to the same place just with a different kind of thought process. Well, let's go through some subtraction. We've got 9 yards, 1 foot, and we're subtracting 3 yards, 2 feet. Now, the dilemma here is that we can't take 2 feet from 1 foot. We actually have to borrow. So we go over here to the 9 yards, and let me erase up above here because we're going to put something up there. We go over to the 9 yards and we borrow a yard. So we're borrowing 1 from the 9, and it becomes 8. Now, the 1 yard that we borrow is really 3 feet. So we take the 3 feet that we borrowed and add to the 1 foot that we already have here, and that gives us 4 total feet. You see, so really this is 8 yards, 4 feet is the same thing as 9 yards, 1 foot. Now we can subtract. 9 feet minus 2 feet, 4 feet minus 2 feet, 4 minus 2 is 2. And then 8 minus 3, 5. So 5 yards, 2 feet. Here we're multiplying 2 feet, 5 inches times 6. And the 6 is just multiplied by both the feet and the inches. And away we go. 6 times 5, 30 inches. 6 times 2, 12 feet. And once again, we're in that situation where we have so many inches here that we can convert many of them into feet and make this a simpler form. And that's what we want to do. Now, you might easily be able to see that multiples of 12 will give us feet. You see, multiples of 12 inches will give us feet. And 24 is a multiple of 12, and it's within 30. So we could think of 30 inches as 24, let me put a plus sign in here. See, this is really 12 feet and 30 inches. Just think of it like that. So this is really 12 feet plus 24 inches and 6 inches. You see, I'm just dividing up the 30 inches into 24 and 6. And in that way, I can see that we have 2 feet right here. So really, it's 12 feet plus 2 feet plus 6 inches. And 12 feet and 2 feet, oh, that's 14 feet, 6 inches. So that's the idea. We're dividing here 3 into 4 feet 3 inches. Now, division is a very special kind of operation in this overall situation involving measurement. 3 doesn't go into 4 evenly. Now, there are several right ways to take care of this, but here's what I would recommend. I would recommend that if we're dividing by 3, that we express the number of the larger unit in terms of a multiple of 3. You see, we really want to rewrite 4 feet as 3 feet plus 1 foot. And the 1 foot we're going to rewrite in inches and put it over here. So that's the idea. So we're making a little conversion here in order to make the division come out evenly for the larger unit. Now, and as I say, there are a lot of right techniques to use with this, but here's what I recommend. I recommend that we rewrite this and think of it as 3 into, now the 4 feet, we're going to think of it as 3 feet plus 1 foot, and we have this 3 inches, and the 1 foot is really 12 inches, and we collect these together, 3 inches and 12 inches, oh, that's 15 inches. So it's really 3 feet and 15 inches that we have here. And now we can go through the division process. Now, I don't really care whether it turns out that 15 is divisible by 3 evenly, but that won't always be the case. It's kind of important, though, that the larger unit be divisible by this divisor, whatever the divisor may be. All right, 3 into 3 goes 1. 1 times 3, 3. You see, the division goes evenly, and we don't have to pay any attention at this point to that conversion idea because we already did the converting. So it's 1 foot up here, and then 3 into 15, 5. So 5 inches. So 3 goes into 4 feet 3 inches, 1 foot 5 inches times. You see, that's the idea. Consider this problem. A concrete block is 9 inches high. How many rows of blocks are required for a retaining wall that is 6 feet high? So these 9-inch blocks are being stacked on one another, a row of them, row after row after row, you see, to make this 6-foot-high retaining wall. Now, how many rows do we need? Well, we need to know how many times the 9 inches will go into 6 feet. So what we're really doing is we're saying 9 inches, how many of these 9-inch units, you see, will go into the 6 feet? Now, we don't want to divide, you know, it is 9 into 6, but we're dividing inches into feet. And that's just inappropriate. We have to do one of two things. We have to change all of the problem into feet, or we have to change all of the problem into inches and perform the division. Now, I think the safest thing to do is to change all of the units into the smaller unit. Now, there'll be more of them, all right, but you tend to reduce the number of fractions and decimals that you have to deal with if you do it that way. Now, we're going to actually look at it both ways, but here's what I recommend we do. I'm thinking that we need to rewrite this as 9 inches into some number of inches right here. Now, how many inches would that be? We want to change 6 feet into inches. 6 feet is how many inches? Well, let's see. We multiply by, now we can use that ratio method, or we can say, well, gee, we're going from feet to inches, we're going to a smaller unit, so there'll be more of them, and we multiply, therefore, to get more, and we multiply by the number of the smaller units that it takes to make one of the big ones. It takes 12 inches to make a foot, so we're going to multiply 6 times 12. So it's 6 times 12 is 72. So it's 72 inches then for 6 feet. All right, so 72. Now we're dividing inches into inches, you see. 9 into 72, 8. So 8 times 9, 72, it goes evenly. So it's going to take 8 of these rows, you see, of the blocks to make the retaining wall. Now, in this division process, you know from past experience that this is 9 inches into 72 inches, or I could write it as 72 inches divided by 9 inches like this. And I want to write it like this just to show you the cancellation of the unit. You see, so the inches cancel here, and when we divide, we get a number which is unitless. And actually, the unit that goes with it has to do with the nature of the problem. It is 8 rows of these blocks that make it the retaining wall. All right, I mentioned that we were going to do it both ways. That is, I said that, gee, we need to change everything into feet or everything into inches. We change to inches here. Let's change to feet and see what that's all about. Suppose we change the 9 inches into some number of feet. You see, we're going to the larger unit now, and it would be 9 inches over 1 using this ratio method, if you will, or rate method. And it's feet over inches, inches down here because of the cancellation opportunity. 1 foot is 12 inches, so the inches go out. And we have 9 times 1, 9 in the numerator, 1 times 12, 12 in the denominator, and we bring down feet, so 9 twelfths. Well, now we change that into a fraction or a decimal or something. So 9 twelfths turns out to be 3/4. Oh, that's 75 hundredths. So 9 inches is 75 hundredths of a foot. And now it is, the division process is one of 75 hundredths into the 6 feet, or 6 feet divided by 75 hundredths. And going through the process, we find, again, that we get 8 rows as expected. Here's another one. A plumber used 3 feet 9 inches, 2 feet 6 inches, and 11 inches of copper tubing to install a sink. Find the total length of copper tubing used. Well, I think it's pretty clear if we're talking about the total length that we're going to add. We're going to add the 3 feet 9 inches, 2 feet 6 inches, and the 11 inches. And we set it up like this. Bam, put a plus sign, and away we go. Now we're adding vertically. And we can add in either direction here. We don't have to add from the right to the left. 3 and 2 is 5 feet. 9 and 6, 15, and 11 is 26 inches. It's just as simple as that. Now, the important thing here is that we kind of have we have more inches than makes a foot, and therefore we want to convert as many inches as possible into feet to simplify this expression for the measurement. And to do that, we can think of, gee, 24 inches is within 26 inches. So we're thinking about it like this. We're thinking, well, let's see, that 26 inches can be written as 24 inches plus 2 inches. You see, and the 24 inches is really 2 feet. And the 2 feet and the 5 feet give 7 feet. So 7 feet and 2 inches, oh, that's 7 feet 2 inches for the total amount of copper tubing.